we have division of algebraic fractions. We know that when we have division of algebraic fractions, we have to do the same operation like for division of fractions. So first we have to copy first fraction. We have 5 times t a to second power over 18. In parentheses we have u b square to second power, and now we have to change division sign to multiplication, and we have to flip the second fraction. It means numerator will go to denominator, so it will be 4ta square, and denominator will go to numerator, so it will be 9u square b. Next, we have to do multiplication, fractions, so numerator times numerator, denominator times denominator. So we will have 5, and we have ta to second power. It means, because we have multiplication here, we have to take to second power every expression in parentheses. So t we have to take to second power and a to second power. So we have 5t to second power times a to second power. This rule is always only for multiplication. When we have multiplication in parentheses, it means we have to take to second power every variable. Next we have times 9u square b. And in denominator we have 18, and we will use the same rule when we have multiplication in parentheses and we have to take this whole expression to the second power. It means we have to take to second power every variable, every number which we have in the parentheses. In this example we have u and b square, so it means we have to take to second power u, so will be u square, and b square we have to second power we have to take, and we have times 4ta square. Next step, because we have multiplication, so first we can check if we can reduce something. We have 5 in numerator, and in denominator we have 18 and 4, so we cannot reduce anything. The greatest common factor for 5, 18 and 4 is 1, so it doesn't change anything. Next we have 9, and we have 18 in the denominator, so we can reduce by 9, will be 1 and 2. And next what we have here, we have t square. We don't have t square, a square, but we have a square here, so we can cancel out a square, and we have u square and u square. So now we have in the numerator 5 times 1 is 5, and we have t square and b, and in the denominator we have 2 times 4 is 8, and we have b to second power, so we have power to power, so will be b, and we have to copy the base, and we have to multiply exponents, so t times 2 times 2 is 4, and we have times t, so this is equal. The numbers we have to copy, we have 5 and 8, and what else? We have t, we have multiplication in the numerator and in the denominator. We have variable t square and t. So we can reduce t square, we can rewrite that this is t times t, and we have times b, and b square, because we have b in the numerator, so here is invisible 1, we can rewrite b to fourth power, but this is b times b to third power, because 4 minus 1 is 3. And now when you can always check, when we have the same base, we have to copy the base, so we have b, and we add exponent. Here is invisible 1. 1 plus 3 is 4. I didn't change anything, I still have the same expression in the denominator. And we have times t, of course. Now we can reduce b with b and t with t. So we have that this is equal 5t over 8b cubed. This is my solution.